Continuing our series on SQL joins. Today we're...
Wait a minute, what are you doing here? Wait a minute, what are you doing here? I asked you first!
I asked you first.
Are you repeating me?
Yes.
I am the very model of a modern Major General.
Classic trope. Well, I guess that means we're talking about left and right joins on today's chapter of Data Bard.
Data Bard, Data Bard, Data Bard, Data Bard, Data Bard, Data Bard, Data Bard,
Data Bard, Data Bard.
Deba, 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 hoi, hoi, hoi.
What you're seeing here is an excerpt of a full-day SQL training workshop from the basic fundamentals all the way up to some pretty complicated scenarios in 8 hours. So tell me if you do like this content, because if you do, I do have more that I can make videos on. Let me know in the comments. I'll be sure to make those sorts of things in future videos if you think it'll be helpful. Now that we've got the structure of Lego bricks that gives us the ability to join, how do the joins themselves work? Here's how joins work in a nutshell. First of all, joins are defined by predicates. To be clear, when I'm talking a predicate, I mean this information on the upper right corner of your screen on a.keycolumns equals b.keycolumns. What's a predicate? Predicate means I take a formula and I can assess whether it's true or false. For example, does the number 2 equal the number 2? I can assess whether that is true or false. 2 equal to 2? That's true. 2 equal to 4? That's false. Okay? So we know that a join requires a predicate. How does it use the predicate? Like the following. When you define a join between two tables, we look at them as A and B in the same way that the Venn diagrams do. So we define the join on a predicate. What actually happens though behind the scenes? Well, we know starting out that table A is going to have so many records, table B is going to have so many records. What happens in a join is all of the records in A get compared to all possible records that exist in B, and we essentially create a logical Cartesian combination of all possibilities of a record in A finding a matching record in B. For all of those combinations, we then assess each combination of records, and we assess for the predicate, does the predicate succeed for the record or does it fail? Depending on the result of that determines what we get back in our result set. Now, in the shift from a join that has no predicate to a join that has a predicate, an important thing occurs. You remember from the cross join that we essentially get a Cartesian product. Multiply the records of one table with the records of the other table. That is the total number of records you can get back. When we get to joins with predicates, we're no longer dealing with two dimensions and the multiplication. We are shifting to a single dimension, or really a line, where we are trying to join these records once to these records over here once, and depending on what we find, that is what we get. Let's be clear about what I mean about success and failure. What does success and failure mean when we talk about the predicate? Success means we find at least one matching record, which means for a record in A, we find at least one successful record in B. That is considered success. Failure means that a record in A looks in B to find a corresponding record based on the predicate, and it finds no match whatsoever. Now, knowing the definition of success, when we have a record in A successfully join into B, those two records now merge together into one really wide row that has all of the columns in A and all of the columns in B for each success. First tip when you're defining joins is your joins have to be very specific, because it determines how many records you get back. If I have a record in A with a value of 1 and I have two records over here that both have a value of 1, A is now going to get duplicated to create two total records, where the columns in A are duplicated and the columns in B are unique. When I'm working with a client and I have to debug queries, more often than not, the first issue that you have to resolve is identify if your joins are innately creating duplicates by not having predicates that are well defined enough. Once you solve that, more often than not, that solves your duplication issue. So this is logically how joins work. All the possible records in A compared to all the possible records in B. What's the rest of the terms for? I haven't even talked about inners, outers, lefts, rights, and whatnot. What differs, and where we then start adding in those words, is what we want to do with records that fail the join predicate. That's the only difference between them. Logically, all joins do the exact same thing that I explained. All records in A compared to all records in B. The only difference is, based on that comparison, we return a different set of records from that comparison depending on the predicate and the type of join that we define. Don't believe me? Let me showcase it in a demo. This now gets us to a point where the join makes more sense. We're finding situations that are more logical. But maybe it's not specific enough. Maybe you're in a situation where this subcategory record, this first record here, doesn't provide us any benefit because it's a subcategory that has no products. And I'm doing an analysis on products, grouping them by their categories. How do I get rid of that record? I need to change to a different type of join, which changes what we do with records that fail the predicate. We move to our next most specific join, from a full join to a left join. How do we define a left join? It's just as easy as taking the word full right here and replacing that with left. And that's where we get the exact same join logically, other than it's not a full type anymore, it is now a left type. Let's run this query. And we get back 606 records back. And you can see the first record that we returned before, product subcategory 38, that had no products associated to it, that record is now gone. Let's formally define the left join knowing this. The difference between a full join and a left join is if a record in A can't find a record in B, we still return the record in A. And the inverse of that, if we find a record in B that can't find a corresponding record in A, we return that record from the right table. A left join says that second part I explained there goes away. A left join says I'm going to take all of my records from A and I want to return whatever I can find in B. If it finds values, let's return those in those columns. If I can't find values, let's return the record from the left table and just populate the right table columns with nulls. But the right to the left doesn't work anymore. A right record, product subcategory, that doesn't have a corresponding product record, these are now removed from our result set. That's the difference between a full join and a left join. What would be a right join then? That would be the inverse of what we're seeing here, where if we find records in product that can't find a product subcategory, we exclude those. But if we have a product subcategory that can't find a product, we return those records. To prove that, I'm going to take this left, or we'll change that to a right. Down to 398 records, and here's where you can see product subcategory key, the right table in the join, still has a value, but everything from the product table is null. That, and correspondingly, we can't find any more records where the product key over here is null. That means those records that showed up in our left join don't show up in the right. What are the situations though where this is helpful? Why would we want to return a query that says, I return products that don't have a subcategory? Sometimes that's actually helpful for debugging purposes. For example, suppose I'm debugging the data that exists in my database and I want to identify products that aren't associated to a subcategory because in terms of business process, that shouldn't logically happen. I can take this left join and I can add in a where clause where B dot product subcategory key is null, and watch what happens when I run this query. I return 209 records back, and they all have the same thing in common. I can see product data for all the records, but scrolling to the right, none of them have product subcategory data. These are all the records that are products that don't have product subcategories. By combining a left join with an is null predicate like this, that is how I get to these two examples in the second row here on the left and on the right. That is what they're talking about. Situations where the record only exists in A and does not exist in B at all. Very useful for debugging purposes. Let's go ahead and comment that out and get back to the main point of our left join. That's a left join. So again, we started with cross. Cross returns all possible combinations. Full adds in a predicate, and if the join fails, we return the record at least once. Left now restricts it to say we are only going to return all records from one table, and we are going to ignore some records in our right table if they don't succeed the predicate at all. That's a lot of content for one video, so we are going to cut it here, but we will be covering the other join types in future videos. So that does bring us to the end of this video, and hopefully this is helpful. If so, like, subscribe to the channel, and let everybody know if they're struggling to figure out how joins work, check out this series for some useful tips and Lego analogies. Have any follow-up questions? Hit me up in the comments. I'll do my best to answer my questions there or in future videos. For now, I'm Data Bard, and I'll see you in the next chapter. Today's chapter may be done, but that doesn't mean the story is over. If you are looking to work with someone like me to improve your data strategy or implementation, go to bakertilly.com/digital, fill out the contact form, and let's see how we can help you take the next step on your data journey.